Hi everyone, welcome to our meeting in Research Statistics. I'm Dr. Afif and today we're going to explore sampling technique, a vital part of any research process. In simple terms, sampling is about choosing who will be part of your study. If you are doing classroom-based research or small-scale project, especially in English language education, choosing the right sample helps ensure that your results are valid and meaningful. When we conduct research, we usually can't ask every single person in a population. It's too expensive, too time-consuming, or simply impossible. So instead we take a sample, a smaller group that we hope represent the larger populations. But how do we make sure our sample is fair and unbiased? That's where sampling techniques come in. This slide introduces us to probability sampling, a category where every person in a population has an equal chance of being selected. This approach minimizes bias and increases the generalizability of our findings. Let's look at 4 common types of probability sampling, each with its own logic and use case. Simple random sampling. This is the most basic form of probability sampling. Every member of the population is listed, and selection is completely random, like throwing names from a hat or using a random number generator. For example, if you have a list of 100 students and you want to choose 10, each student has an equal chance of being selected. Stratified sampling. In stratified sampling, the population is divided into strata or groups based on characteristics like gender, proficiency, level, or age. Then random samples are taken from each group. This ensures that important subgroups are proportionally represented. For example, if your population is 60% female and 40% male, your sample should reflect that. Cluster sampling. Sometimes it's easier to select groups rather than individuals. In cluster sampling, the population is divided into clusters, like classes, schools, or regions, and then entire clusters are randomly selected. This is useful when working with a large or geographically spread population. Systematic sampling. Here, you choose every nth person from a list. For example, if you want to select 10 out of 100 names, you could choose every 10th person. You start at a random point, then apply a fixed interval. It's simple and structured. So use probability sampling when you want your result to generalize to a larger group, and when you want to identify all members of your populations. Now let's look at the non-probability sampling. In this approach, not everyone has an equal chance of being selected. This is often more practical for classroom research, but it's more prone to bias. Let's break down into the types. Convenient sampling. You select participants who are easy to reach, like your classmates or nearby students. It's fast and simple, but may not represent the whole population well. Purposive sampling. You choose participants based on the specific criteria relevant to your study. For example, if you're studying students with high anxiety, you deliberately select only those students. This is great for targeted research. Snowball sampling. This technique is useful when studying hard-to-reach populations. You start with 1 or 2 participants and they refer others. The sample snowballs growing as more participants are recruited. Quota sampling. You set a target number of specific groups, for example, 10 males and 10 females, and then select participants non-randomly to meet those quotas. It ensures representations but lacks the randomness of probability methods. Use non-probability sampling when your target group is specific, your population is hard to access, or when you are doing exploratory research. Now it's your turn. Think about your own research. Who is your population? What kind of sampling makes sense? you are doing research on speaking anxiety among shy learners, purposive or snowball sampling might be best. If you want to generalize to all first-year English majors, try stratified or random sampling. Create a sample for each technique. Try selecting 10 students using simple random sampling. Then imagine selecting based on proficiency level for stratified sampling. Practice makes understanding deeper. Thanks for watching. Sampling might seem like a small step, but it has a big impact on the quality of your research. Choosing the right technique ensures your data is meaningful and your findings are valid. See you!